Okay, so today our goal is to just solve both exponential and logarithmic equations. So an equation that involves a logarithm, how do we solve it? An equation that involves an exponential, how do we solve it? Okay, now you've done this before. There's maybe one type of problem we're going to do today that you haven't seen, but otherwise you have solved a majority of these types of problems before. All right, so if we have an equation that involves an exponential piece inside, what are some strategies we can use? Okay, we have what's called the one-to-one property. That's if our bases are equal, then we know our exponents have to be equal. Okay. What if we don't have something that looks like that? What if our bases are different? Or we only have one item that has an exponential piece to it? What would we have to do?
I don't know what it's called, but you just make the bases the same. If it was 4 to something and then 64, you make them both full.
Okay, so you force this to happen?
Yeah.
Force the one-to-one property? Okay, that would be good. That would be good. What about something like this? What about something like number 25 or number 23? Okay, there's no way you're going to make those have the same base. What would our option be? Let's see, 3 to the 2x equals 80. 3 to the 2x equals 80. I can't use the one-to-one property because it's 80, not 81.
Can't you just rewrite it into a log?
Ah, yes. Okay. We can rewrite an exponential equation into a logarithm. That forces the variable out of the exponent and onto the other side of the equation. Okay. One thing that I will say though, if you go to rewrite into a logarithm, your exponential piece better be isolated. Okay. Your exponential piece better be isolated. So let's go to the flip side. If we have a logarithmic equation, what are some strategies we can use to solve for x? Probably going to be pretty similar, right? Okay, Gabe, give me one. We could rewrite it into an exponent. Here again, you would want to make sure that the logarithm is by itself, nothing added, subtracted, or multiplied or divided to it before we rewrite it. Okay. What's something else we could look for? The inverse. Could you go a little bit more detail on that? Okay, would you say that if we have a logarithmic equation, its inverse would be exponential, right? So rewriting it as the exponential, that would kind of be using that inverse idea. Okay. Do we have something like this for logarithms? We have the one-to-one property. And then there's something else that we learned how to do with logarithms that could be helpful. What did we spend Wednesday doing? Oh, we are going to definitely have to utilize the change of base. If we want to evaluate with our calculators, we will need to know that. What else did we spend Wednesday doing? Okay. possible that we will need to use either the expanding or condensing properties to rewrite our logarithmic equation into something that we can use. More than likely, it's going to be the condensing. Okay? You may have to condense one side so you only have one logarithm instead of two. Okay? So this is what we're going to do. I have 3 examples that we're going to go through. And then I'm going to give you a handful of examples to do inside of an activity at your tables. Okay? So I would say 3 of these 5 problems you have probably seen ones like them before. 2 of the 5 might be a little bit new to you. Okay? So let's start with this one. All right, where's our variable? In the exponent. Okay, our variable is in the exponent. The first thing that I see is there's this 2 out in front. That 2 needs to go somewhere else. Okay, how do we get rid of that 2? We need to divide it over. So we have 5 to the 2x plus 3 equals 30. Oh, what do I do? I subtracted. I'm so sorry. Sorry. I subtracted. Okay. Hey, you guys caught it right away, though. Way to pay attention. Okay. Now, is there any way for us to use that one-to-one property? No. Okay. So, since we have our variable in the exponent, we should probably rewrite this as a logarithm to force it out. Okay. So log base 5 of 16 equals 2x plus 3. Okay? So what we're going to have to do is in our calculator, we're going to have to figure out what log base 5 of 16 is. And then to isolate x, we would have to subtract 3 and then divide everything by 2. Okay, so in your calculator, please evaluate log base 5 of 16. From that, we would subtract the 3 over, and with that difference, we could divide it by 2. Okay, what are we getting? Okay, and thank you. I do want 3 decimal places. Okay. Okay, now you need to know the change of base formula, but if you have a calculator like mine, can I show you a trick? Go to math. And do you see this log base right here? Just keep arrowing down.
Yes.
Oh. TI-83, you're not going to have it. Gabe, stop looking. Sorry.
Oh.
Okay? You're welcome to use that, but you still need to understand the change of base formula, okay? All right. Cool. Keep going here.
Max, you were right.
Please write down this next question. E to the 2x minus 4e to the x minus 5 equals 0. does this remind you of anything? It reminds you of an equation? Talk at your pods real quick. Does this have any familiarity to some other type of equation to solve?
Oh.
Okay, Max, you said this looks like we could factor, right? Okay, so let me ask you this. If I ask you for x squared minus 4x minus 5, you would tell me that this factors to x minus 5 and x plus 1? Okay, well look over here. What's e to the 2x squared? Excuse me, that was wrong. What's e to the x squared? E to the 2x. E to the x times e to the x. We add the exponents, e to the 2x. So this is a trinomial in disguise. We can factor this to e to the x minus 5 times e to the x plus 1. E to the x squared is e to the 2x. So it follows that trinomial pattern. Is that crazy? Okay. So what we have is each factor set equal to 0. Okay. We have our variable in the exponent. So we would need to isolate it first, and then we could rewrite. Are you okay with e to the x equals 5? So then we could write log base e of 5 equals x. Monique, what is natural log of 5?
1.609.
Okay. There's one answer. Over here, we have e to the x equals negative 1. So when we rewrite that, log base e of negative 1 equals x. It's undefined. What's the problem? Can't have negatives inside of our logarithms. So show me that, algebraically negative 1 would work, but like with our exponents, but we can't put it inside of a logarithm. Okay. Are you guys okay back there? Is there a question? Okay. All right, so that would be one of the problems that maybe you haven't seen one like that before. Okay, let's look at another one. I like this one. What is the problem with this one? They don't have the same base. Is there any way we can force them to have the same base? No. Okay? Okay? And if we tried to rewrite, please don't do this along with me, but if we tried to rewrite like log base 3 of 4 to the x minus 1 equals x, even that's not even helpful. Do you agree? Okay. So I'm going to give you a strategy to solve these problems. Okay? I don't know if you remember me saying base E is the most useful base. Okay, we can do a lot with it. Okay? Do you agree that if I do something to one side, as long as I do it to the other side, we balance out? Okay. So if I say, all right, I want the left side to be inside of a natural logarithm, as long as I do it to the other side, it's all right. Okay. Why would I do something like that? Okay. If we have logarithms, we have properties that we can use for logarithms, right? So what can happen here is I can take these exponents and rewrite them using our properties of logarithms. That x can be multiplied out in front of the natural log of 3. And the x minus 1 can be multiplied out in front of the natural log of 4. Our exponents can become multiplied, whatever's multiplied out in front. Okay, that's what we worked on Wednesday, correct? Okay. All right, well now we don't have any exponents. That's nice, right? Okay, so let's do this. X minus 1 is being multiplied to the natural log of 4. So let's go ahead and multiply that through. So we would have x times the natural log of 4 minus 1 times the natural log of 4. Okay. Now we're solving for x. Do you agree? Okay, now this may look a little familiar, maybe flash back to chapter 1 here. I have two different terms that have an x, and I want to solve for x. Okay, it would be a good idea if they were grouped together. So I'm going to go ahead and subtract over x natural log of 4. That way my two terms that involve an x are together. And if I have two terms that have something in common, what can we do? We can factor that something in common out. Okay, so we could factor out an x. And even though it doesn't look pretty, we can still approximate it in our calculator. To solve for x, we can take this natural log of 3 minus natural log of 4 and divide it over. So in your calculator, you could take the natural log of 4 and divide it by the quantity natural log of 3 minus natural log of 4. Or the natural log of 3/4 if that's how you want to write it. You should get 4.819. Please try it in your calculator to make sure you can get that number. Can we get there? All right, you ready to look at our two logarithmic examples? Okay, now before I move on, I want you to think about this. Have you seen a problem like this before? No, this is like our pre-calc exponential example. Okay, so out of everything that we're doing today, some things are familiar, this is not. You're going to have to make sure you do this problem in the homework tonight. Okay. Other stuff may come back to you a little bit quicker. This is new. You're going to need to practice it. Okay? All right, two more examples. Here's the first. variable is inside of our logarithm. Okay, there's also a square root involved. Okay, so we need to decide what our first step is going to be. Any thoughts?
Isn't the square root the same as like to the 1/2 power, so you can move the 1/2 in front of the natural log, so it'd be like multiplying?
Oh, okay, so you said this is like a 1/2 power, so we could write 1/2 natural log of x minus 8 equals 5, like that. So then we could write the natural log of x minus 8 equals 10, right? And now that our natural logarithm is by itself, we can rewrite it. This is log base e to the 10th equals x minus 8. Sure? So e to the 10th plus 8 equals x, which is going to be a very giant number, but please find it for me. All right, e is like 2.7, so when we take it to the 10th power. Gabe, you have it for me?
Yeah, 22,034.
Ah. Okay, to get a number that big. Okay. Now, let's say that you didn't have the vision of Emily and you didn't put that 1/2 power out in front. You cannot square both sides unless the radical is by itself. So if you did not change that to a 1/2 power, you would have had to rewrite base e to the 5th power equals the square root of x minus 8. And then at that point, you could square both sides to, again, get e to the 10th equals x minus 8, and we get to the same place. Okay? But I do want you to realize that you would have to rewrite that logarithm first before you squared both sides for that square root. Okay? Which maybe it's safer to just write it as a power, so you're not tempted to do that. All right, let's get to our last one here. All right, I see 2 logarithms. Can we use the 1-to-1 property? Riley, why not? You're shaking your head.
Well, I thought you just condensed it.
Oh, Riley thinks we could just condense them. How do you feel about that? Okay. If we had 2 logarithms that are equal, we could use that 1-to-1 property. We can't make these 2 logarithms equal because we have that 2 right there. Okay? But what we could do is we could condense to 1 logarithm. So log base 2 of x divided by x plus 1 equals 2. Okay? Well, now that we have only 1 logarithm, because we condensed it, we can rewrite this into an exponential. We have base 2 to the 2nd power equals what's inside? 2 squared equals x over x plus 1.
Well, last year I remember we would put a 2 underneath the log base 2 and then multiply on the other side too. So we crossed out the log base 2 and then have 2 squared equals. It's the same thing.
It is, okay, so you're saying instead of rewriting, you exponentiated both sides, saying 2, 2, boom, like that?
Yeah.
Okay, yep, same thing. We're still going to get that 2 squared equals x over x plus 1. Okay. How many of you did that last year? Okay. Emma, what teacher are you coming from? Okay, either way, we're getting to the same place. Okay? So now we have 4 equals x over x plus 1. What do we do? Okay. Do we like having a fraction? Not particularly. So we can take this and we can multiply it over. So this is a 4. So it becomes 4x plus 4 equals x. Here's the thing about logarithmic equations. Logarithms are a little bit picky about what you put inside of them. Do you agree? Okay. They're picky eaters. All right. Negative 4/3. If our x value is negative 4/3, that can be okay. We cannot put negative 4/3 into either one of those logarithms from the very beginning because it would make both of them negative inside. Which means, yes, algebraically, negative 4/3 satisfies this guy right here, but inside of the logarithm, negative 4/3 is not allowed. So, there's actually no solution. Okay? I need you to show me all of the answers that you get, and any of them that you can't plug back in, I need you to cross out so that I can see them, but know that that's not an answer that you want. Does that make sense? All right. Braden, I want you to come sit up here. Riley, I want you to slide over to class 3. Oh, we have the back number, darn it. Okay. I'm going to have you hop back to pod 8. Okay. All right. I'm going to put you in partners the best that I can. But what I want you to do, I'm going to give you a set of dominoes. Now, they're not like the fun dominoes. They're math dominoes. On the right side of each domino is a problem. On the left side of each domino is an answer. What I'd like you to do is take a domino, doesn't matter which one, complete the problem on the right, find the domino with the answer, place it next to it, and then complete that problem and find the answer, put that next to it. And what should happen is your last domino should be the problem that answers your first domino. Does that make sense? So, in your notes, you can do this. I don't care if you line them up. I don't care if you make a big circle so they wrap around. But I would like you to do these problems, work together, you and your partner. And then when you have them completed, raise your hand and I'll check over them. Okay.